Now, where we left off yesterday, we found the slope of the tangent line, okay, which is right there. Okay, right here in green is the slope of the tangent line, and what I circled in red, 1 over that is the slope of the normal line, which is what is being asked for. Okay, so we found the derivative, and then we took the negative reciprocal, and we got the negative reciprocal to give us the normal line, which is perpendicular. Okay, so for instance, if this was the tangent line, the normal line would be just like this, perpendicular. And that's what we're looking for in this problem. Okay. By taking the negative reciprocal, that's what we found. So far we have, right, let's go, 4√2. Now we need to plug it into the point slope equation so that we can find the equation at that point, right here. Okay. Y minus y1 would be 2 equals x minus x1, which is 0. So when we distribute, okay, we end up with just 1/4 root 2 x. Okay. If we look at our answer choices over here, we don't have that there. What we need to do is get rid of a fraction, because none of these have a fraction in it. So what we'll do is multiply times the reciprocal of our slope there to both sides. Let's do it this however you like. Okay, and then distribute that to those two. These cancel, leaving us with this right here. Keeping in mind, where do we get the 8 from? That's 4 times 2. Actually, positive. Negative 4 times negative 2 equals 8 times root 2. Gives us this here. Now, if we look at our answer choices, we got something a little bit closer. Negative root 2, 4 root 2 times y. And looks like B, if we just put this over here to the other side. Okay, and then we have our answer B. Okay, for number 8, we need to realize that when we're asking for the average value between 2 points, we're looking for the slope of the secant line between those 2 points. Okay, and we'll start from the largest number, which is -1. This is our rise. The slope of our secant line is the rise over the run. That's the y value at -1, the y value at -3, and the run is the x values, -1 minus -3, leaving you with this. Okay, after you plug in, you have that right there, and then condensing it even further gives you this, and finally simplifying it all the way through, you end up with this. Okay, -4, -4. Number 9, we have the instantaneous rate of change is our tangent line. Okay, instantaneous at 1 point is the tangent line is what we're looking for. So we're looking for the derivative, and I went ahead and already changed, renamed the square root portion to 1/2 to the 1/2. Okay, now we just take the product rule, and what I'll do is I'll take the first portion times the derivative of the second. Okay, and then I'll end up with right here. Keeping in mind that when we took the derivative here, we used the chain rule. So here's the exponent, here's the inside, we leave it alone. Here's the exponent -1 times the derivative of the inside right there. Okay, and I believe there's a mistake right here. That should be, the derivative of the second would be 6t squared minus 3. So I'll go ahead and fix this. And we're set. Okay, so right away plug in the number. We have a 0 we can plug in, do that, and you'll end up with it right there. Okay, so everything with the zeros go away. You're left with 4 times 1/2 plus 4 raised to the negative 1/2 plus times 3 plus a negative 3 times 4 raised to the 1/2, and bringing that down looks like this. Okay, so we have our 4, we have our 1/2, we have our times 4 raised to the negative 1/2. Okay, so that's 1 over the square root of 4. Then times our 3 here, okay, and plus our plus. Okay, we got left side, and here's the right side now. We got our negative 3 and times the square root of 4 right here. Okay, and just simplifying, we'll go ahead and reduce that to 2. So now you have 2 times 1 over 2 times 3 plus negative 3 times 2. Those go away. Now you have 3 plus a negative 6. And finally, we have negative 3. Okay. Okay, now here's where we have a couple of chain rules in one. Probably about 3. Okay, we have all of this as our inside function first. Okay, so when we take our derivative, we're going to bring that 3 over. Leave the whole inside function alone, all of it. Everything that's being raised to the third, leave it alone. We're taking the derivative with respect to all of the inside squared. Now, our inside function, our outside function is this. We're leaving this alone now. Times the derivative of cosine, which is negative sign. There's our outside function. Leave the inside function alone. Okay. Now, here's our inside function. Take the derivative of that, which is 2. Okay. Derivative of 2x minus 4 is 2. And so we're going to multiply the 2, the negative, and the 3, giving us negative 6. And then what we have left, cosine 2x minus 4. Keep in mind we're squaring the whole thing, not just this, the whole thing. We're not just squaring that guy. Okay, and then we already brought the negative to the front. And so we're ready to plug in pi over 2. Okay. So when you plug in pi over 2, you end up with this. And so now we can cancel. I just plugged in the pi over 2 where the x was. And now we're left with pi minus 4 for both. Okay. Now, first, I'm going to go ahead and just bring up our options, our answer options. Okay, so get this guy out the way. And those are our answer choices right there. So that's what we have to choose from. And cleaning it up, we have this right here. Now, be careful because these two are two different things. Okay. If we have this, we're only squaring this portion, pi minus 4. But we're not. We're squaring the whole thing, and that changes the whole answer. And don't know why that happens, but for some reason it disappears every time we hit the undo. Okay? And as you can see, our answer choice is right there for us to see the difference between these two right there. We're not squaring this, we're squaring the whole thing. So that's our answer choice. For 11, the tangent line for the derivative. Rate of change, we're looking for the derivative. Okay? Instantaneous rate of change, we're looking for the derivative. And right here we have a product. So we'll need to use the product rule, but when we take the derivative of this portion, we need to use the chain rule. So we should have, if I take the derivative of the second part first, I should have something like this. And the common mistake to make is when you take the derivative of the inside here, don't ever forget to that negative right there, because you'll end up with 0 minus 2x. The derivative of 0 minus 2 is negative 2. Okay, you will I see that a lot. I see people forgetting the negative sign there, okay, which I once did too for a while. So now we can just go ahead and plug in the 1. So we end up with this right here, and I'm going to clean it up by multiplying these two together, and well, as well as the negative. Ending up with this bad boy right here. Okay, so we used to have our -6. 1 minus 2 is a -1, but when you square it, it's positive. When you cube a negative number, the negative doesn't go away. Okay, so you know that this was -7. Okay, and be sure to also show the notation of what you did. Okay, so what we did all the way down here. This gives us the slope of the tangent line. Okay, now we need the equation of the tangent line. From the looks of it, the only answer that is available is this one, but we need to make sure we did it correctly. And maybe we messed up on the negative sign, maybe not, because here's another option that could be possible. So plug it in. Y1 is equal to -1. And there's our slope, x minus 1. Okay, just distribute. Okay, and let's bring that -1 minus 1. Oh, excuse me. This is not it. Okay. Our 7 times 1, -1, is positive 7. There we go. Leaving us with it. Indeed, letter A is our answer. Okay, pretty simple here. No tricks. Just find the derivative of our function. The derivative of sine is cosine. No problem there. Okay, and all we need to do now is just plug in the derivative at pi over 3, which is at 60 degrees. Okay, the x value at 60 degrees, remember we got 3, the x values, 2, and 1. Okay, the x values at 30, 45, and 60. Okay, and these are just reversed for the y values, but we are only interested in the x values. So cosine the x value at 60 degrees is positive 1/2. And the option is right here, although it's not on your paper, as we addressed earlier with the mistake I made for you guys. Make your life a little bit harder than I should have. My apologies. Okay, our last one, same thing. No big deal. Just take the derivative once, then take it twice. And here's our constant, leave it alone. Derivative of cosine is negative sign. Let's put a parenthesis so we don't mistake it for subtraction. Okay, sine of x over 2. All right, now we need to take the derivative of x over 2. Okay, and that's the same thing as writing 1/2 x, which is much easier to see. When you take the derivative of 1/2 x, you're just left with 1/2. Okay. 2's cancel, so you're left with the first derivative, negative sine 1/2 x. And now let's take the second derivative. Negative sine is negative cosine of 1/2 x times the inside, the derivative of the inside, 1/2. So we have negative 1/2 cosine of x over 2. Either way you write it is okay. And here's our answer. If you have any more questions, you can send me a text message through the chat.